And I think you can see my screen. I'm going to make my screen a little bit smaller, and I think you can see my screen. I'm going to open the recent project, this data analytics. No, what is the project? Intro to R project, which we were using. And today we are going to cover two new topics. One is how to convert data from long format to wide format, and one is the basics of dplyr. And I am going to start with the basics of dplyr today, but we are going to continue with it, I think, tomorrow as well, probably tomorrow. Now let me create a new file, R script. And what is it, seminar 5 or seminar 6? What do you think? Session 6, I guess.
Yeah.
Session 6.r. Now we are going to need two data sets today. One is PIAC data set. You probably have it already. If not, then I'm going to copy it to the chat as well. Read CSV, HTTP, www.utee, ESEPO, PIAC.eng.csv. And other data set we are going to use is, I'm going to show you a little bit, this animals data set, which is the same, HTTP, www.utee, ESEPO, animals.csv. This is a new data set that you do not have yet. It's a very simple data set, but I'm going to use it today. Now, in this introduction to R week 4 materials, I'm actually starting with R Markdown, but I will skip this R Markdown part now. I'm going to talk to you about R Markdown one later day. R Markdown is amazing thing on its own. And now you had, I saw it, it was 3 hours workshop on ggplot. I hope you got a lot of new information about ggplot. I just have to say that you cannot learn too much of ggplot. This is most of what I do is in ggplot. When I get new data, I visualize it to see what's going on in the data. Before I start any kind of analysis, I have to see it with my own eyes what's going on with ggplot. And when I want to show my results to somebody, then of course again I'm using ggplot. ggplot again. So then there is the ordering factor levels. Let's forget about this as well. I'm talking to you about, I don't know, did you cover the ordering factor levels in the ggplot session, that how to make? I will find time to cover this as well. But first I want to show you what is data in long format and data in wide format, and why this is so important. It will be a little bit hard topic at first to catch, because it's a little bit it screws with your brain. But it is so important that I promise you, with every single analysis, you need to do some data wrangling, data from wide format to long format and back with every single analysis. So I'm going to teach you about two new commands, pivot wider and pivot longer. And this is something that is extremely hard to do in Excel, for example. Some of the easiest things, it's easy to do in Excel, but some of the things are that it's very hard to do with Excel, which is very easy to do with R. So if we look at this animals data set, there's animals, there is a bear with a length of 10, with a width of 7 and age of 3, and there's a cat length 4 with 3, age 5. This is how we see the data usually in the wild. This is considered to be data in wide form. It's data in wide format. So there is a number of measurements on one line. but R sometimes likes data in long format. And I'm going to show you now the same data in long format. Do not do it with me. I'm going to convert it to a long format. Pivot longer animals holds is vector of length, width, and age. Now I have to first load in library tidyverse. Library tidyverse. And now I'm going to pivot this data longer. And you see, this is the very same data, but it has only one measurement on a line. And this is called data in tidy format or data in long format. So there is bare, then what is measured? Length is measured. What is the value? 10 is the value. Bare, what is measured? Width is measured. What is the value? 7 is the value. Again, bare, age 3, cat length 4, cat width 3, cat age 5. So this is data in long format, and R loves data in long format. So when you download data from some data source, it is usually in long format. Now, I am going to just show it to you again. Do not do it with me. I'm going to load library Eurostat, and I'm going to for example, download some data set from there, some random data set. I don't even know what data set it is. We will see it in a second. And it shows. Let me make it a little bit more. Let's say this is labels. Type is label. And this shows you data in long format again. So when you download data from the internet with R, from data sources, then usually the data is in long format. It says what is measured, who are measured, gender who are measured, age group, geography, the name of the country, when is it measured, and then what is the measurement. So one measurement on a line, tidy data, not white data, but tidy data. Now let's take a look how to do it ourselves. If you look at this animals data set, then to convert it into longer format, you will say pivot longer. Now pivot longer wants to know what data set is pivoted longer. Animals data set is pivoted longer. Now it wants to know which columns will it take together into a name and value variable. So let's say the columns to take together is length, it's vector of length, width, age, and you see now it is animal name, then length, what it was, this is in name and value pairs. Or we can just take only two of these variables, only length and width, for example. And now it shows bear with age of 3, its length is 10. Bear with age of 3, its width is 7. Cat with age of 5, its length is 4. Cat with age of 5, its width is 3. So you can do a lot of this kind of, you can convert this data set to whichever way you want. And again, at first it looks like a little bit obscure. Why do you want to do this? I will show you why you want to do this, and this is something that you really want to do. So when you in the practical life, in real life scenarios, it's something that you do with every single project. Now let's create this long data, length, width, age, and let's write it into a data set. So for example, animals long, and I am writing this long data set. What I created with this pivot longer, I wrote it into the animals long data frame. So now I have animals long data frame, which has animal name, then variable called name, variable called value. And inside this variable called name, there are all these previous column names, and inside this variable called value, there are all these values which were in the matrix, in the data frame. If you want to pivot it longer, if you want to show it in like this, you would not probably show it in your report. But if you want to show it in your report in the wide format, if you want to pivot it wider, sorry, then you would use pivot wider. Now, pivot wider wants to know which data set is pivoted wider. So animals long, and then it wants to know from which variable should it take the new names of variables. So names from which variable come the new names of variables. Let's say names from name, and then values from which column should we take the values and populate the new matrix that we are to values from. We want to take it from this value column here, values from value. And you see it created from this long data set, it created this wide data set. Now, again, it's a little bit hard at first to get your head around this. I know this, but it requires some practicing. But if you have this kind of practical problems, then you will see the value of this pivot longer and pivot wider data set. Pivot longer and pivot wider this approach. Now, there is a small your turn. Actually, it's not so small, but I'm giving you some time. It starts from page 5, at the end of page 5, and it continues on page 6. And this is one of the cases where this pivoting longer approach works, where what you want to do. So there is a your turn at page 5 to 6. Now I'm going to give you some time to try it and see if you manage to do it, but I'm not going to give you too much time because I have some other topics to cover, so I will at one point do it with you. But please try to start with this. I'm resuming recording now. So what I did, I did the first exercise already. You take the animals data set and you look at the results. Which variable are pivoted into longer format? Which variables they first were names of columns, but now you put them not names of columns but into one column, and then the next column will be the value. So it will be name and value, name and value, name and value pair. So these columns that are taken together are length and width. Pivot longer animals calls length and width vector of columns here, and it will show you this data in a little bit longer format than before. Two variables are put into this name and value pairs. And now for the second one, for second one, I'm going to use the GDP dataset again. So GDP is read CSV, HTTP, www, UTE, build the seppo. What was it? GDP.p CSV, GDP estimate.csv. So whenever you load in this kind of data from CSVs, then you have to again convert the date values to be dates, so that R understands that what value is a date, what value is not a date, and how is the state how is the state okay, Sven, you had a question. Yes, so here are actually additional parameters here in the pivot longer. Yes, I noticed now as well that I had, so names to is measurement, comma, values to is, for example, value or values. Then it pivots it longer so that this you just can give them these new columns that you create, you can give them a name. For example, names to measurement, then the column name will now be measurement, values to values, then the column name will now be values. The animals data set, how to get it, I didn't copy it here. So it was like this. I'm copying it here as well. So it's just a very easy small data set. Yes, I'm sorry. It's a little bit hard to give, these lectures online fully because I do not see your faces, your struggling faces when it's a little bit hot in Estonia. So when I am giving it face to face, then I can see who is struggling, who is not, who needs some help, whom can I go to walk to and help. And usually I have a couple of assistants who walk around and try to find people who are in trouble and help them out. So it is much more.
One question: when we assign the new variable, like for example, name measurements, it results in an error in the code. Names and the /2 equals measurement. When I assign this variable, it shows the object, value to object, measurement not found.
Did you put measurement into the quotation marks?
Yes, I think so. Yeah, I did. So let me check it again. Yeah. Names. Yeah, measurement, quotation mark.
I have a question, like how to decide that where to put this parenthesis, like in pivot longer, in names to is equals to, you added measurement in parenthesis. But if you look on the above, for names from is equals to name, you did not give this name into parenthesis. So how to decide that what variables to be added into parenthesis?
I can give you a lot of theories where the parentheses are required and when they are not required, but believe me, you will not remember anything of this. You will try and ever use this. So here you need the parentheses. Before you did not need the parentheses. We are in modern R right now, and in modern R, in many cases where in basic R you would definitely need parentheses. In modern R, you do not need the parentheses, but these quotation marks. You do not need the quotation marks so often. But really, you will get it by doing it. I am sorry. It's way more complicated than it seems. Where the quotation marks are required and where they are not required. So actually here, I think pivot wider than I can use the quotation marks.
I could manage it. Yeah, it's now okay.
So I can use the quotation marks here as well, but I don't actually need them. But here you need the quotation marks. So why? Well, this is called non-standard evaluation, NSE in R, and it goes it's a little bit you just try and you will find out where the quotation marks are required and where they are not required. Now to GDP. So GDP, and when I look at this head GDP, then it shows me that it has date, which is year, month, and day. So how to convert it into date variable, I'm going to use lubridate package, this amazing lubridate package. Library, lubridate, and GDP date, I'm going to overwrite it to is year, month, day, GDP date, Control Enter, and now it's a date. You asked how Abdri, you asked how to fix it. You see the label, the type is label. You have type is lably, not label. It has to be label. You see, written exactly like this. So now if I want to visualize this GDP, you remember what we did first time we looked at this GDP, let's say names, or let's look head GDP again. There are two variables here of interest, first estimate and latest estimate. And now there are two ways to visualize this. One is to do two geom lines. One is first estimate and the other is latest estimate. But another way to do it, and in many cases what you want to do, or if you want to facet this graph, for example, then you need to do it. You need to convert this data set into longer format. And now just it is hard at first, but to understand this, but when you get it, then you will start loving it. So I'm going to create GDP long, and I'm going to say that this is pivot longer. What data set am I pivoting longer? GDP. What are the variables that I'm going to make into longer format, this name and value pair? Cols is a vector. And with what will I put here? First estimate and latest estimate. So this is how I converted it longer. Now let's look at this data. Again, let's remember, this was how this looked like before. Year, quarter, first estimate, latest estimate, date. This was how this data looked like before. Now the GDP long version, GDP long, it looks like this: year, quarter, date, then name. The name is either first estimate or latest estimate, and value, which is this value, which is what it was before. And now it is much easier to visualize. Now you can visualize it like this. Now you can visualize it like this, that ggplot. What data are we visualizing? GDP long, AES, X is date, Y is value. Plus geom line. Sharon, yes, I am showing you now why you converted it to longer data. Now you can use this one geom line and saying that, for example, AES color is name. And you see with two lines, you now visualize both of these lines and you have automatic labels. One is first estimate, one is latest estimate. Again, Sharon, I can understand your question, and I can understand this at first it looks this kind of obscure, and why are we doing this? But in many cases you want to do it. For example, if you want to now pivot, if you want to now plus do this, that plus asset wrap tilde name. Now you can do this asset wrap. You can put these graphs next to each other. With this wide format of data, you could not. It would not be possible to create this kind of thing. Yes, you can do this as well. This one, if you want to.
Like no, what is the mistake here? Because it is not pivoted. It is
What?
still the same. Like I tried to use this command, but my data is not kind of pivoted. It is not longer. It is still the same.
But it writes it into GDP long. Look now at GDP long, not GDP anymore. It is definitely
sorry.
pivoted.
Sorry. Yeah. Okay, thank you.
Yes. So this was a little bit about this pivoting data to longer and wider format. We will use it later again. I will show you cases where you want to do it. And but for now I show it to you first time that what it is to pivot the data to longer format or wider format. And I have had, believe me, I have had my friends sending me in some I don't even know the word in English, how to some crazy data sets, and asked me to get them into normal format. And this pivot longer, pivot wider are the tools to use to whatever format the data is. You can convert it to a normal, nice looking table, what you can present or what you can analyze. Then okay, then I see there is a so for example, now there's actually your turn actually continued, but I haven't made it there. So for example, again, when do you want to pivot data? I copied to you 2 lines of code. I'm copying it to me as well. So if I read in this kind of data, you see, if I have data in this format, like here, like this GDP PCA, it's in long format. Let me see if I can just look at the head GDP PCA. So this is a data set in long format. It shows the world at date 2019. Value of the measurement is 16,944. What is measured is indicator. It is some GDP per capita per PP. Tidy, you need to load in library tidyverse. Then you will find it. So this data is in long format, but in this kind of long format, you do not present the data to your customers or to your, I don't know, to your supervisor or you want to show this data in different format, not like this. So what you would do is you would take this GDP PCA data and pivot it wider. Pivot wider GDP PCA. Now you take, for example, names from is, let's see what variable, let's say date, values from is value, and now this data looks, oh dear, it doesn't look like anything that I wanted to do. Because first you need to remove date CT variable by assigning null to it. Okay, GDP PCA date CT is null. And now pivot longer. It's still not. Why is it not showing it to me in correct format now? there's some X variable. dplyr X. And now it would show this world, Estonia, Finland, 2019, 2018, 2017. It would show it in wide format. I have to remember to remove this exercise from there. It's a little bit too hard, or make a more interesting exercise here.
I have a
Note
question.
to self.
I have a question. So what does this mean? Like you did date null and the PCAX null. So what does these commands do to the data set?
To the data set, it removes these variables from the data set.
So like these columns are removed, like the date column is removed by using this operation.
By writing null to it, it will remove these columns from the data set. Yes. So there are no such columns anymore in the data set.
Okay, thank you.
Ovi, you ask when do you make it wider and when to make data set longer? Well, it depends on your need. If data set is in long format, then it is easy to analyze and easy to visualize. But you do not want to show data set in long format to your for example, you almost never you want to put into your report data like this, that bear length 10, bear width 7, bear age 3. But in many cases, you want data like this for analysis. You want to, when you want to give your data in a table for your report, then you almost always want to give it like this. That says bear with length of 10, with width of 7, with age of 3. But we will see it later. We will see it later where we need it and where we do not need it. I will show you some cases where you really want to make the data set longer and where you really wanted to make the data set wider. At least I think I will have something like this in the future. Right now, I just wanted to show you the two commands. When you need it, then you really need it, and then you have seen these commands. But now, people, now to the second most important part of our little seminars here. So first most important part is ggplot. The second one is dplyr and grammar of data manipulation. Again, created by Hadley Wickham, the same guy who created this ggplot, the ggplot in R, the ggplot package in R. The same guy created this dplyr. And dplyr is again part of tidyverse packages. If you load in tidyverse, library tidyverse, then it automatically loads in dplyr. And what Hadley said what he was thinking about when he created dplyr was that, you know, 70% of what you do, the analysis part of what you do is the data. It is maybe 10-15% of your time. Most of the time, what you are doing is you are trying to wrangle the data into the right format. And he tried to make it as easy as possible. So he tried to think out that, okay, what would be the, and you know, when I'm teaching tidyverse, when I'm teaching this dplyr, I am a little bit envy you, but I also feel a little bit bad for you because you will not understand how great it is because you have not done it in the old way, how it was done in the old way. In the old way, some of the things that I'm going to show you, they took a tedious work and a lot of work. And you could make a lot of errors, but in dplyr, it is elegant. You only need something like 5 basic verbs. And what is a verb in R in dplyr? Verb is a function. So we'll take a look at 6 basic verbs now: select, filter, mutate, group by, and summarize. Select, filter, mutate, group by, and summarize, and let's say arrange as well as a sixth verb. So these 6 verbs will get you amazingly far. And let me show you these verbs in action. But first, before we get into this, I'm going to show you piping operator. Percent is bigger than percent. This operator I'm going to show you what this does. So I hope you have pyac loaded. If not, then please load pyac. I'm going to copy it again, because now I want to show you some things, but I also need you to do it with me. But first, I'm going to show you one-liner. So how to get 5 top wage earners from pyac dataset. 5 top wage earners. This is done like this. For example, top N, pyac, 5 income. And what it gives you is, it gives you a new data set that has 5 lines from pyac, and these people have the highest income in the pyac. It selected top 5 income earners from pyac. So top N is this kind of function that selects you. It's not an important function actually, but you can write the same one-liner. You can write with 2 lines like this: pyac and then top N 5 income, and you will get the same result. Now you might ask that what the hell am I doing? Why? That was a nice one-liner. Why convert it to the two liners? Why to do it like this with this and then operator? But you will see later that when you have a lot of these things coming after each other, you are putting this and then and then and then and then and then and then it starts to make sense. So what this and then operator does, and I really need you to understand this, it takes the end result of this pyac, of this last line, and puts it into the first, as a first parameter of the next function. So it takes this pyac and puts it as a first parameter into this top N, and you see then it's the first parameter, it expects this first parameter, and it works like this. It seems pointless at first. Why would anyone convert this to do something like this? But you will see in time how it will help you and how it will make your code very easily readable and very easily interpretable. Now, let's start with the first important verb, and this is select. Select. What select does, select takes columns from the data. For example, let me create a new data set, pyac.small, or let it be not pyac.small, but pyac underscore small. And I'm going to say, starting from pyac, and then new line. Select. And now I can write into the select, I can write all the names of the columns I want to select. For example, gender, income, what was there more, children, this kind. So I only wrote these three columns into this pyac small data set. Only these 3 variables.
What is the difference between select and filter? Because last time we used filter to make the subset of the data. Here we are making subsets of the data, right? So last time we used, I think, filter to make the subset of the data. So what is the difference between these two?
Select selects variables. Filter selects rows.
Okay.
So now we are selecting variables. Filtering selects rows that I only want those rows where gender is male, for example. But here I select only, if you look at this data now, head, pyac small, then you can see it only has 3 variables: gender, income, and children. Either has children or no children. Now, select is something that you are not going to use so often, but still you are going to use it. Especially if you are going out to some business field and then you have a very big data sets, and then you want to select some fewer variables there. Select has some helper functions. For example, I can select gender, income, children, comma, starts with, let's say, what should we start with something, starts with, I don't remember if there was anything starting with an head, yeah, small, yes, numeracy was. So for example, or what it starts with, what it ends with, what it contains, so you can find all the top. We can use mutate as well, but Ovi, it is top n, not just top, but top n. We will see how to create new variables with mutate as well. But first select. So starts with, ends with, contains, this kind of things you can use here, so that you can select only these variables that you need from a big data set. The second one is something we already, or for example, what you can do is, if you look at PIAC, names PIAC, then you see that it has 16 variables here: sequence ID, age, gender, employment status, living with spouse, children, blah blah. When you want to select some variables from one variable to another variable, then you can do it like this: PIAC small is starting from PIAC, and then select, for example, gender, colon, and literacy, and then let's add health to it as well. Then now it takes all the variables which are between gender, starting from gender to literacy, and then adds health variable as well. So if you look at what you have in PIAC small now, then names PIAC small, then you see they have gender, employment status, blah blah, and health. Then let me introduce you next function. So this was select, the least used, but okay, if you want to remove some variable, for example, you don't want education, then you write minus education. And now you have all the variables which were there before, but education is gone now. Now the education variable is not gone, is not in here anymore. So something you ever so often you want to do. Now let's look at the next command, and this is called summarize. And soon I'm going to blow your minds, but not yet, not yet. Yes, if you look at PIAC small, view PIAC small, then you see that these are all the variables, not just the headings. You selected, you had 16 variables at first. Now in PIAC small you have 8 variables only selected, only 8 variables selected. So the rest of them are dropped. Now let's look at summarize. It summarizes data. Let's look at how it does it. So I'm going to start from PIAC again, and then I'm going to summarize, and I'm going to say that, let's say, average wage is mean of income NARM is true. And it created me a data frame with only one variable, average wage, and it has this mean of income, which is 899 euros. Doesn't look like much, does it? Well, I am going to show you how it will look like much. So I can add actually other variables here into this line. For example, saying that n is n. Now it counts all the people. It counts the lines. This n counts lines, and it gives me that there are 2,604 people. Average wage is 899. Or you can add min or max here. So, for example, min wage is min of income, and now RM is true. I'm going to put it into the next line. So it creates you a nice data frame with these values. It is a data frame, but it gives out. So you can then put this data frame into report, or you can visualize it, or whatever. Again, nothing very special until now. Now, when I'm at this point, I usually play some opera. I don't want to play it because then the YouTube will again not let me upload the video.
Like,
Ishren, no, you want select, not filter. We are getting to filter. You are running ahead. We are getting to filter in a second.
Okay.
You want select. But first, let me show you. You know, I like opera a little bit. The older I get, the more I start to like opera for some reason. The reason is probably that, you know, when people get older, then they do not hear the high voices anymore so much. So that opera starts to make sense to you. It's not just all the time. But what I'm going to show you now, I like even more. So what if you want to get the average wage by gender? And let me add one line after PIAC before summarize. Group by gender and then. And Karmau, you have the average wage by gender, you have N by gender, you have min wage by gender. You have a nice little data frame showing you by groups is summarizing stuff. Or not only gender, let's say gender and education. Let's add education variable in here, education. And you have it by gender and education. So you have a nice data frame, which is that people with people who are female with basic education, their average wage is 506. Females with higher education, their average wage is 865. There were 1,753 people like this. The minimum wage was 34.7 euros. So you can get this kind of summarizing tables extremely easily by using these two commands, group by and summarize. Group by which variables you want to group them by, and summarize to so this what is not available, remove is true. If I just take mean of income, as there are many not availables, then R will give you exactly, R will give you not available as an answer. But this means that remove the missing values, just like Charlie said. Thank you, Charlie. So this is how we rock, people. Now, before this, you see, there is just 3 lines of code here. Before this kind of logic, you had to write some 2-4 cycles to get to this. Now you can just group by, but whatever variable you need, by month, by, I don't know, division of your company, by country, by whatever, and whatever you have in the data set, which variables. And summarize, find these summarizing values, what you want to find, the average income or minimum income or whatever, length of some stay in hotels. And you will get a nice data frame, that has you covered. Now there is one thing I want to add. After you have done this group by, then a good thing to do is to add ungroup at the end. Then it removes this grouping variables from the data set. It doesn't show you now, it doesn't seem to matter right now, but at one point this group by, because it adds groups to the data set, these groups will stay. Actually, summarize will take one group away and leaves other group into the data. It's not even in the conspect. I haven't written this ungroup, but I am thinking now that I should add this.
The ungroup function is the opposite of group by or something else?
Opposite of group by. It will remove all the groups from the data.
Oh, okay, thanks.
So it is just a good practice to always add this ungroup after you have done the summarizing or after you have done everything that you want to do, because otherwise the data set would have groups inside it that you would not see the groups here. Actually, it will, you see, if you know from where to look. If I run this, then you see it says that this is a double 6 times 5 groups gender. So it is grouped by gender. So if you do something else now, another summarize, it thinks that it considers that the data has this, it does it by gender. It doesn't do for the whole data set. It does it for each group separately. So this is why it's a good practice to add this ungroup at the end of everything, where you, after you have done your group by, you have done your summarizes by group, you add ungroup. Not required, but good practice. Ooh. Then these were the group by and summarize commands. Then there is filters, what you have already looked at. Filter. And filter filters rows, takes subset of rows. But we will look at it in 10 minutes. So we will start again at 15 or 10. I think 10 minutes is good, yes.
Yeah, 10 is okay.
Yes, we will look, we will see again in 10 minutes.
Okay, good.
I'm going to stop the pause the recording until then. Oh, I am good in this. I haven't forgotten to put it into record, not once. I always have put it into recording. So there was a question, can we have this descendings in group by and stuff like this? Yes, we can. There is a function called arrange for this, and we will look at arrange in a second, but let's first look at filter. So you remember, so it has, if you are looking for a man or you're looking for a woman, it has not been easy. It has never been easier than now that you have R. So, but now we are doing this with and then. So, for example, piarc and then filter. For example, gender is equal to, what could the gender be? So for this, I can check it for its unique piarc gender. It can be male and female. For example, let's look for a male. Gender is male, and you can add this different parameters here. Now remember, 2 equal signs, not 1 equal sign, not 3 equal signs, 2 equal signs to make it exactly to be made. Or if you want only some man who has very good or excellent health, then you look what could the health be, unique piarc health. It could be fair, good, very good, excellent, poor. So you can say health percent in percent, and the health was with big H, percent in percent, and now a vector of values where the health should be either very good or excellent. And now it gives you all the men whose health is either very good or excellent. Let's get a little bit deeper. Let's say you are looking for a man whose income is bigger than, let's say, 500, and now it filters out everybody whose gender is male, whose health is very good or excellent, or income 500. So you can add this by comma, and we have used this before, this filter command before. It takes the data set and it looks every row. If the gender is male, then the row remains. If not, then it throws the row out. So it is filtering the data set. Now Now there is your turn. So what is the difference between and then and percent in percent? Percent in percent, this looks into it, it says that health has to be one of these. And then it sends to the next line. It sends the end of this line, so PIAC, to the next line as a first parameter in this filter command. So remember, before we did it like this: filter, what data set are we using? PIAC, what are the conditions? Gender is male, so you can create only men. But now what we are doing is PIAC, we can do it the same thing like this, only men is, starting from PIAC, and then filter gender is equal to male. If you are only adding this, doing this one command at a time, then it doesn't make sense. It doesn't make much sense. But what we can do is we filter gender is male, and then group by, for example, education, and then summarize. For example, average wage is mean of income, NRM is true. And then arrange by average wage. And now you have this, and now if you look at only men, I wrote it into the only men, then you have this new data frame, which is arranged by average weights from smallest to highest. And you can do all of your analysis like this, that you start from PIAC. You can actually write here that read in PIAC from the internet, and then filter, and then group by, and then summarize, and then arrange, and then do something else, and then do something else, and then write out the graph. So you can like go on with these and thens and write all your code like this, and it is very easily readable. Very easily readable. So starting from PIAC, and then let's do the filtering, and then let's do group by, let's add groups to the data, and then let's do the summarizing, and then let's arrange the new data set. So there is a small your turn. There is a small your turn at page number 9. Your turn at page number 9. Just arranges it from smallest to biggest, or biggest to smallest value. We will look at this arrange in a second, in a little bit with a little bit more detail. But so your turn at page 5. Try to do this. Create a new data frame containing only people. Thank you, Elia. Your turn at page 5. I will give you some, I don't know, 7 minutes to do it. I'm going to stop the recording for this time. So if you're looking at YouTube, then take your time and then continue when you are ready with your turn. So this is your turn at page 5. You start from PIAC, and then you are going to filter the data set. Filter. So for example, that gender has to be female, but you can add more conditions here. So health has to be either excellent or very good. So health, percent in percent, and vector of values. I am not tiring you to tell you that this percent in percent, this is very important argument, not argument, but operator. So you need it in many cases. So health has to be in the following, either very good or excellent, comma. And then you want that the numerous is at least 300. The person has to be quite smart. So numeracy is bigger than or bigger and equal than 300. And then summarize you take this, you do this filter, and then you summarize. You want to know what is average monthly income. Average income is mean of income, and RM is true. So it shows that the average income for these people is 996. But if you want to add something to it, for example, you want to see how it is by education levels, and you can say group by education in between here, and you will get this, that higher education people's average income is 1,084, second education people's average income is 673, and there are no people who is lower education whose numerus is bigger than 300, whose health is very good or excellent, and whose gender is female. So this is how you solve this. Now, you know, the wonderful thing, if you ever have a bad day, then you can think of me. So I cannot pronounce one single letter in Estonian language, and the letter is R. I cannot pronounce it correctly. And all my life is around R. I work in R, I teach R. Everything is about R, and I cannot pronounce the effing letter myself. My family is very happy when I tell them again that I am going to teach R. So how I start my Estonian language courses is actually I tell them that when I was young, you know, and I was sent to learn R, then I misunderstood. I learned the wrong R. Now, let's create some, yes. Okay, let's create some data sets so that I can show you what a range does. So starting from PIAC again, and then let's group by, for example, let's group by study area, for example, and then summarize. Find average income over study areas. Average income is mean income, and RM is true. You see, it shows you the study areas. Let's add one more. Let's add, I always like to know how many people are in this group, which we are summarizing, which we are finding the data about. So let's add that N is N. This N just, it counts all the rows in the group. It counts all the rows in the group. So we can say that there are people whose study area was agriculture and veterinary. Their average income was in this data set 746 euros, and there were 305 people like this. Now, what if I want to know whose average income was highest, and I want to, you know, arrange it by this average income variable? Then you would add, and then arrange, and by average. But now you need to arrange by this last variables that you have here. Now remember, from here on, when you do the and then this data set goes to next line. This data set, not the original data set anymore. It has grouped by the original data set, then it has summarized the original data set, and now you have a new data set. So if you do and then what you can do is you can work with this new data set. So I created this average income variable here. So I can arrange by this variable, average income. And now it shows me the same data set, but it is arranged in a way that from smallest to highest value. So you can see that agriculture and veterinary is the smallest average income. The highest average income is science, mathematics, and computing. If you want to arrange the data set from highest to smallest value, then you would put around this average income descending, DESC, descending. And now it arranges it from highest average income to smallest average income. So this was a range. And then the last verb I want to show you is mutate. Mutate. Now we have looked at select, we have looked at group by, we have looked at summarize, we have looked at arrange. So only thing yet to show you is mutate. Mutate allows you to create new variables in the data set. So for example, I am overwriting PIAC, starting from PIAC and then mutate. For example, let's add together numeracy plus literacy. These are, let's say, the skills. Skill sum is numeracy plus literacy. Yes, sorry, I did not ungroup, and it's actually it would be a group. So this ungrouping. So if you do group by, I group by to one study area, one variable, and then you do summarize, then it automatically removes one group level. So I only had one grouping level here. The summarize removes this grouping level automatically. If I would have multiple grouping levels, for example, study area and I don't know, gender, then now it removes one grouping level, it removes the latest grouping level, so it removes gender and it leaves the study area inside here. So as you said, actually a good practice would be to do ungroup at the end, because then you don't have any groups in the data set anymore. And you would see this, that males in social sciences, business and law are earning the most, and females in general who have graduated general programs are earning the least, if you group by study area and gender. So, but mutate, if I do like this, I'm overwriting PIAC, starting from PIAC and mutating, creating a new variable skill sum, which is the sum of numeracy and literacy. Control Enter. Then if you look at PIAC now, if you view the PIAC now with big V, view PIAC, after doing this mutate, you view the PIAC, then you will see that it has now one more variable, skill sum, and it has this, it is sum of numeracy plus literacy. So this is how to add variables or convert variables or whatever you want to do inside mutate. But remember, if I wouldn't have written into PIAC this, if I'm just starting from PIAC and mutating, then it does not change it, it just shows it to me on the console. So I always have to overwrite PIAC or create a new data set, and inside this new data set you have this new variable. Now let me show you what this group by and why I am recommending you to ungroup. You can, yes, of course you can, but let's not overwrite PIAC now. Let's write something like PIAC small, starting from PIAC, and then filter. I don't know what you want to filter. Gender is male or something else, and then mutate, and then do something else. Yes, you can use them. You can use them as much as you want. Now I'm going to show you something about this mutate, and I'm going to show you like this, that I'm going to create PIAC. I'm going to overwrite PIAC, starting from PIAC, and then I am going to mutate, creating a new variable. I'm going to create a new variable which is a relative wage, and it is income divided by mean of income, and RM is true. So you understand what I do. I divide the person's income by the average income. So I will see if the person has higher income than average or lower income than average. Now if I do it like this, and now take a look, take a concentrated look what I am not concentrated, but take a look what I created. I'm going to view here, and you see the first person's relative wage is not available because he or she didn't have wage. The second person's wage is 0.83. So he or she has 83% of average wage. But what if I group by before? I add group by gender here. And then now it finds this average income by gender. And now if you look at PIAC, now, then you see the relative wage of second person is now 1.03, not 0.86 anymore. So it shows the relative wage inside the gender. So we know that this is a woman, and when using mutate, is it possible to specify the column where you want this variable to appear? No, it will automatically go to the end. But if you want to relocate, then there is a command called relocate, and this will put your variable wherever you want. So we know now that this is a woman, that her wage is 1.03. You do not address it with mutate. It automatically does what it needs to do. So it will create when the income is not available, then the result will be not available for this row. But look at now what I'm doing now. I'm going to remove this group by. I'm going to remove this group by, and I'm going to do this again without grouping by. Now you remember, without group by, the second person's income was 0.86. With group by, it was 1 point something. You would expect now that if I do this, then the second person's income will be 0.86 as well, because I do not add this group by. But it is not. It is still 1.03. Over here, I'm going to address this in a second. It is still 1.03. And why is this? Because when I overwrote PIAC in the last line, you see, I did this group by gender, and then I did not ungroup. So I wrote into the PIAC, I wrote these groups already. I wrote now the PIAC is grouped data. And even if you do not do a group by anymore, it is still grouped by gender. So this is the reason why you always want to, after you do your thing with group by, you want to ungroup. Because then in the PIAC data set, it is not grouped by gender anymore. I know it is a little bit, again, it's a little bit too much, this information, but I want you just to be hearing this. So, Ovi, you asked that why are we seeing NRs when I have written NRM is true here? Because we are dividing every person's income with the average income, and we find this average income who is not available removed. So if person's income is not available and we divide it by some value, which is 1,500, for example, then the result will still be not available. So we will have not available in the data, but we cannot find average income who is not available inside it. Yes, it is statistically correct. What I did here. Because otherwise I cannot find average income for females or males at all. But now I wanted to find this relative wage. Ooh. There is, my dear friends. Again, I want you to practice this a little bit more. I depend on point estimate here, yes. I want you to practice it a bit more. I want you to practice a bit more, and I want you, because in this relative wage, well, we didn't do any science here. I just wanted to, well, it's not an error. It depends what you want to do. If I want to have relative income inside my variables, that who is earning more than average inside my, you know, I'm not finding the relative income inside the whole population. I am finding the relative income inside my sample, inside my sample. Yes, definitely. You do not want to. Okay, now it depends what do you. Okay, in some cases, if you consider wages and you want to know what is the average wage, considering that people who do not have wage have zero wage, then you would add zeros to them. Yes. Right now, I found the wage considering that the others, considering average wage for wage owners, I found. But if you add zeros instead of not availables, then you find the average wage of people, considering that those who do not own anything, they own zero. Now, there is your turn at page 10. Please look at your turn at page 10. I want you to practice this a little more, because the practicing is everything that I want you to do all the mistakes. So page number 10, your turn. And I think we will not be able to do much more today. So maybe I'm showing you, let's see, I will give you some 10 minutes for this, or 7 minutes, because this dplyr is kind of the most important part apart from ggplot. And I want you to practice it a bit and make your mistakes with me.
Simple question very quickly. So the main point of mutate function, the main point is to shift it or to change the position of the data or the column, or what's it? Actually, I didn't catch up at the beginning.
The main point is to, if you want to create a new variable in the data set,
yeah,
using other variables. Or for example, let's look at this GDP data set again. Then what I did right before, I did like this GDP date was year, month, day, GDP date, or something like this.
Yeah.
With mutate, I could have done it like this. GDP, I am overwriting. It's page 10, L4, yes. So with mutate, I would have done it like this, starting from GDP and then mutate. Date is year, month, day, date. I would have written it like this with mutate.
Yeah.
In the model now.
I mean, is it to change the position or to access a new data, or to change the format of the data?
To change the format of the data, to create new variables inside the data. For example, if you want to find, I don't know.
Is it can be used to convert the data?
Yes.
Okay, perfect, thanks.
I am coming back in a second, but please try to do this page 10. It's your turn. So how is it going? I had a call now, work-related call, but I am back in business now. Should I write it? We are actually getting into the time where we should finish. So I'm going to write it. So remove everyone who does not have health indicator from PIAC. Find the median and average. Is it this? No, it's not this. Find the average wage and numerous score by gender and sub-study area. For those whose age is over 30, arrange it by the numerous score, write it to a new data object and write the data object out as a CSV file. So what I would do with this, I would start from PIAC and then I would group by study area and gender. This when I am showing you it in a second. Group by study area and gender. And then I am filtering. It doesn't matter whether I filter it before or later. Age is bigger than 30, and then summarize so that I want to find average wage and numerous scores. Average wage is mean of income, and RM is true. Group by, yes, it is used with categorical variables. Otherwise, it will do something very bad. It will group by every single value of variable. Average wage is mean of income, and average numeracy is mean of numeracy, and RM is true. So if you do it like this, then it writes it in this data table, data frame, it writes it into your, and then, okay, let's add this ungroup as well, and ungroup. It writes this data table on the console. If you want to write it into a file, then you can here say, and then write underscore CSV, then file is my.csv, for example, and it writes it into the my table CSV in your project directory. So it goes over, and so add a new data set to PIAC dataset so that it would equal literacy over numeracy. I am going to overwrite PIAC starting from PIAC and then mutate. And let's say, what should I call this? Literacy over numeracy? Oh dear. Lit over num is literacy divided by numeracy. And now I have new data, new thing, lit over num, that is literacy over numeracy in the PIAC dataset. If you check the PIAC dataset with view, now you will see that the last variable you have there is lit over num, and this is equal to literacy over numeracy. Okay, so I'm going to stop the recording now, and then I can talk with you how to export it. This actually is write CSV exports it into my table CSV. Or you can write it into a data set, for example, my data, and then write CSV, my data, comma, file is my table CSV. Now you write it into a data set, my data, and write CSV, what file, what data object are we writing, my data object, into which file, my table CSV, console enter, and it writes it. Love is in the air. La 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 la. Now